Hey guys, this is Mr. P. We're going to work on the Scatterplots and data analysis cheat sheet right now. So when you have a type of association that shows an overall trend or a pattern between two sets of numerical data. So a trend is like a pattern, and you can do that if you have sets of numerical data. I think our book might have called that quantitative data. All right, so if there's a positive association, the data move in the same direction, which means that as one variable increases, the other also increases. The number, for example, the number of hours a person works and the amount of money they earn. You can see here both of these scatterplots have a positive association where as one increases, the other increases as well. One of them is linear and one of them is not linear. All right, a negative association is when two sets of data move in opposite directions. As one increases, the other decreases. So a real-world example here would be the number of hours a person works and how much free time they have. So again, here's two negative associations down and to the right. One of them is more linear than the other one. And then if there's no pattern or no trend, we say there's no association. So one set of data has no effect on the other set of data. So the number of hours, for example here, the number of hours a person works and something that's totally not related, like the length of their hair. It's just one example. So you can see here's our scatter plot. There's not a clear trend anywhere. Which takes us to our next idea here, a trend line. So when a scatter plot is linear, a straight line can be drawn to show the overall trend, and we can then use that to make predictions about what might happen for future numbers. So the equation of this trend line here, well, again, the same kind of rules that we need. We need a y equals mx plus b. So we first need to think about what's our y-intercept. Well, it looks like we're crossing the y-axis at 20. So we would have a plus 20 there. And we need to find out what is our rise over our run. Well, we're always going up 10 and right 1. So since our slope is 10 over 1, that means it's y equals 10x plus 20. So then using this, predict what the value of y would be when x is 15. When x is 15. So that would be y is equal to 10 times 15 plus 20. Well, 10 times 15, that's 150 plus 20. 150 plus 20 is 170, and that's what y equals. All right, predict the value of x when y is 120. So this time our y is a value. So this is 120, and that's equal to 10 times x plus 20. So our first step here is to take 20 away from both sides. So 100 is equal to 10x. Then divide both sides by 10. X is equal to 10. Mean absolute deviation, everybody's favorite thing. The mean absolute deviation is the mean or the average distance, not averages, the average distance that the data points are from the mean. So there's 3 key steps here. You first need to find the mean of the data. Then, once you've found the mean of the data, you find the distance that each number is from the mean. So that's a subtraction problem. But remember, it needs to be positive, so you use an absolute value around it. And then step 3, once you've found all of the distances, you find the mean of those distances. So, for example, it says the ages of 5 people in a store are shown below. What's the mean absolute deviation? Well, our first step would be to find the mean. So I'll show you with a calculator over here. The mean here, well, here I am. Let me get to a new calculator page. So we would add them all up, 23 plus 44 plus 51 plus 19 plus 33. And there were 5 numbers, so I divide by 5. So my mean is 34, or we call that X bar. All right, now I need to figure out how far is each number from the mean. So I would do 34 minus 23. And I need them to always be positive, so the next one I would do the absolute value of 34 minus 44, then the absolute value of 51 minus 34, and then the absolute value of 34 minus 19, and then the absolute value of 33 minus 34, which is 1. All right, so then I've got these 11 or these subtraction problems. So now I take their mean. So that would be 11 plus 10 plus 17 plus 15 plus 1, and I add 5. So I divide by 5, and I get 10.8. So the mean absolute deviation of this set of numbers is 10.8, which means that the average distance from each person's age from the mean is 10.8.